Hello, ladies and gentlemen. Welcome to the end. Welcome to your last video. Congratulations. This is the last part of Algebra 2 that you need to, that you are responsible for. So, let me be the first to say congratulations. And let's get into it and let's see what we are dealing with. Geometric series. Geometric series is exactly similar to arithmetic series, which is what we talked about last. You are looking for the sum of something, except remember in a geometric sequence you are multiplying by a common ratio over and over again. So here you're looking for the sum of a common ratio. Or I'm sorry, sum of a geometric series where you're going to use a common ratio to multiply. So you're looking for the sum of things that you multiplied together. So let's take a look at what we're talking about here. Suppose you email a joke to 3 friends on Monday. Each of those people send a joke to 3 people on Tuesday, then on Wednesday, and so on and so forth. How many people have read it on Friday? So on Monday, you sent it to 3 people. On Tuesday, they sent it to 3 more people. On Wednesday, they all sent it to 3 more people. On Thursday, they all sent it to 3 more people. And on Friday, they sent it to 3 more people. So how many people saw it each day? Well, on Monday, 3 new people saw it, plus you. So they multiplied it by Tuesday, that's 9 people. All right. On Wednesday, that's 27. Thursday, that's 81. Friday, that's 243. So the sum total of people that have seen this is going to be 363 plus you, so a grand total of 364 people. So now the sum for a geometric series, the sum of the n terms by an arithmetic series, should be a geometric series, will be this. These would be your 2 rules. Now, what I would look at is the differences between the 2. So let's start with that. First one. Here, I'm given A1. I know what the ratio is. I know what n is. All right, so I know the first term, the ratio, and n. So if I know those 3 things, I'm looking here. For the other one, I know my first term, I know my nth term, and I know my common ratio. So I don't necessarily know what n is, but I know what the nth term is. So if I'm looking nth term, and I know my first term, and I know my common ratio, then I'm going to go after this one. So let's take a look at number 1 and see what we got. So for number 1, I know the first term, I know the nth term, I know my common ratio. So for this one, I'm leaning towards here because I don't know what n is. N is nowhere to be found, so that's why I'm going to use this one. So let's take a look. My sum is going to be 1,000 minus 125 times 1/2, all over 1 minus 1/2. So when I do that, $937.5 divided by 0.5 is going to be 1,875. So there is my answer, 1,875. So now here, take a look at what I got. Maria arranges some dominoes so that after she knocks over the first one, each domino knocks over 2 more dominoes when it falls. If there are 10 rows, how many dominoes does Maria use? So row 1 is 1 domino, then there's 2 dominoes, then each one knocks over, and so on and so forth for 10 rows. So in the first one, there's 1, in the second one, there's 2, the third row, there's 3, and it's going to go on, so on and so forth. So how many does Maria use in 10 rows? So my 8 of the 1 is going to be 1. All right, my common ratio is going to be 2. I'm multiplying by 2 basically every single time. So after 10 rows, which one am I going to have? Well, I'm looking at this because I know those three things. I know my first term, I know my n, and I know what my ratio is. So the sum of the first 10 is going to be 1, 1 minus 2 to the 10th. So here you want to make sure you're going to raise it to that power first over 1 minus 2. So when I do that, 2 raised to the 10th, 1 minus that is going to be negative 1023 all over negative 1. So it's going to take 1,023 to deal with. So it's going to take me 1,023 dominoes to get all this set up. So take a look here. Contagious diseases can spread very quickly. Yes, they can. Suppose 5 people are ill during the first week of an epidemic. And after that, each of those people spread it to 4 people. By the 10th week of the epidemic, how many people are affected by the illness? So 5 people, that's like A sub 1. 4 people by each person, that would be kind of my ratio, R. 10 weeks, that's going to be my N. So again, I know A to the 1, I know my ratio, I know N. I want this one. So my sum after 10 weeks is going to be 5 times 1 minus 4 raised to the 10th all over 1 minus 4. So 4 raised to the 10th, 1 minus that is going to be 5 times negative 104,875 all over negative 3. So when I multiply that times 5 and divide it by negative 3, I get 1,747,625. So it's going to be spreading to 1,747,625 people. So that's going to go pretty fast. All right, so taking a look here, find A1 in a geometric series where the sum is that and the R is that. Well, if I know my common ratio, I know what A1 is, and I know my sum, and I actually know the n is going to be 8, I want to use this one to solve. All right, I know that the sum of 8, that's an S despite how it looks, sum of 8 is going to be A1, which is what I'm looking for, 1 minus the common ratio raised to the 8th over 1 minus 3. So if I do this, 39,360 A1. 1 minus 3 to the 8th is 6561. So if I take 1 minus that, I get negative 6560 over negative 2. So 39,360 equals A sub 1. 6560 divided by negative 2 is going to give me 3280. Now it's a one-step algebra problem, so life is easy. So if I take that divided by 3280, I get 12. There's my answer. Now, sigma notation is actually a pretty simple, convenient way to talk about summation notation, or talk about basically what a series is. So this one is going to be a geometric series because I'm multiplying over and over and over again. So 2 times 3 to the n. So I start with n equaling 1, I stop with n equaling 5, and I add all of those. So I would take 2 times 3 to the first, and that gives me 6. 2 times 3 to the 5th, and that's going to give me something big, 486. So that would be a geometric series, so that would be my first and my last. So and then I would fill in with 2 times 3 squared, 2 times 3 cubed, and 2 times 3 to the 4th, and I would add all of those up. All right, so that's basically what it's going to do. If you come show me your calculator, I can teach you how to do this pretty slick. So let's take a look here. If I want to figure out my sum, I know this is geometric. That means I can use one of these rules. So like I said before, first term, n equals 1. That's going to be 2 times 3 to the first. Last term, 2 times 3 to the fifth. So we already figured out that's 486. That's 6. I know it's geometric, so I can do this. So I can say, so I can say 6 minus 486 times 3 all over 1 minus 3. So when I do this, let's see what I get. 486 times 3, 6 minus that, divided by -2, should get me 726. That's going to be your answer. Now for this one, take a look, because there's a multiplication piece, but there's also an addition piece. This is neither arithmetic or geometric, so I can't follow these rules, and I can't follow the arithmetic rules. What I need to do is this. What I need to do is actually crank out these numbers, or let my calculator do a lot of the legwork. I should get an answer of 808, because if I take 5 to the first plus 7, that's going to equal 12. 5 squared plus 7 is going to equal 32. 5 cubed plus 7 is going to equal 132. 5 to the fourth plus 7 is going to equal 632. Let me slide that up. Then I'm adding these things. So I should get an answer of 808. So you got to recognize it's neither arithmetic or geometric, because I've got both. So I've got both elements. I'm multiplying and I am adding there. So come talk to me with questions. Like I said before, come talk to me and I will get you, teach you how to do it in your calculator so that can do a lot of work for you. Otherwise, come talk to me with questions and good luck on your quiz.